Okay, so after reviewing radical expressions in 9.1, we're going to talk about rational exponents in 9.2. Well, let's first review of the rules of exponents. Those rules we did discuss in beginning algebra in sections 4.1 or 2. I'm just going to review those for you, okay? If you're doing the product of two exponential expressions that have the same base, we keep the base and add the exponents. If we're doing power to power rule, x to the m and then another power n, you multiply the powers mn. Product to power rule, if you have x times y to the power n, you distribute the power, x to the n, y to the n. Quotient to power rule, x over y to the n, x to the n over y to the n, as long as you don't divide by 0. Any base to a 0 power is 1, as long as the base itself is not 0. 0 power rule. And if you have a negative exponent, sorry, x to the negative n is 1 over x to the n. If you have quotient rule, you know when it's product, you multiply the exponents. When it's quotient, you subtract the exponents. Keep in mind when subtracting, you do numerator minus denominator, okay? And if you end up with a negative exponent, then you put it under 1. And then the shortcut rule, if you have a fraction to a negative exponent, if you want to get rid of the negative exponent, you flip the fraction. So y over x, and this becomes a positive. You just flip that. And this is the handout that I'm talking about. It's part of your notes. Look it up. It has what we went over and some examples, and it tells you what you need to do for every rule. So in 4.1 and 4.2, we did integer exponents. Now we're going to do rational exponents. What happens if the exponents are fractions? So we know from 4.1 and 4.2, 4 squared is 16. 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. And we did a 0 power to get 1. What happens if we have 4 to the 1/2, for instance? How do we get that? Well, if you put this in your calculator, 4 to the 1/2, you get 2. And also in your calculator, if you do square root of 4, you get 2. If you try 1/3, 8 to the 1/3, you get 2. If you do cube root of 8, you get 2. If you try 16 to a quarter, you get 2. If you do 4th root of 16, you get 2. So it looks like when the numerator is 1, the bottom is going to be the same thing as the index. And the top actually is going to be the exponent, which we don't put because 8 to the 1 is 1, 4 to the 1 is 1. Okay? So as a general rule, a to the 1 over n, it's the nth root of a to the 1. So that's what happens when we have a fractional exponent. So if you look at 58, page 752, 58, page 752, it gives you 7th root of 7p squared q, and it tells us to write it using rational exponent. Remember, 7th root is 1 over 7, so 7p squared q to the 1 over 7. That goes to the bottom, and this is a 1 goes to top. Now in 62, you have the exponent. They want you to write it in radical expression, so the bottom is the index and the top is the power, so that's a 1, which we don't really need to put, but I put it anyway. Now back to number 20, page 752. How do we evaluate 625 to the 1/4? So that's like doing 4th root of 625, which we get 5 if we put it in our calculators. Number 24, you have negative 1000 inside the parentheses to the 1/3. Again, 1/3 in a power is like cube rooting and everything goes under. cube root of negative 1000 is negative 10. If you look at 28, 1/16 to the power 1/2, that's like square root of 1/16, which is square root of 1 is 1, square root of 16 is 4. Alright, so we gotta be careful though, like I'm giving you real examples here. If you have negative 256 with the negative 256 inside the parentheses to the 1/2, that's square root of negative 256. So everything inside the parentheses goes inside the radical and it's not real. Now, if we do not have parentheses around the negative 256, the only thing that's going to go under the radical is the number itself, and the negative stays inside, because this is like having negative 1 times 256 to the 1/2. And that's going to be negative 1 times square root of 256, which is negative 16. So big difference. Be careful, okay? If the negative is inside the parentheses, it goes with the number under the radical. If it's not inside parentheses, it stays outside the radical, always. Alright, so say you have number 30. Again, let me just remind myself what page I'm on. So I am on page 752 still. So how do we evaluate 25 a to the 8 to the power 1/2? And it says, simplify, assume all variables can be any real number, use absolute value symbols when necessary. So remember, we use absolute value when the index is odd and the exponent on the answer, when the index is even and the exponent on the answer is odd. That's when we use absolute value. So when we have a 1/2, we get square root of 20, everything inside the parentheses is go under. Square root of 25 is 5. Square root of A8 is A4 because we divide the 2 into that. 5 is positive, A4 is positive. No need for absolute value. 36, negative 64 t to the 9th to the 1/3. Again, 1/3 is cube root. Everything inside the parentheses goes under the radical. Since we have an odd index, no need for absolute value. Cube root of negative 64 is negative 4. 3 divides the power twice, so it's negative 4t2. Alright, another example. If I have 16x to the 4th to the power 1/4. Well, a power of 1/4 is like 4th rooting. 16x to the 4. 4th root of 16 is 2. 4th root of x to the 4 is x to the 1st. This is even and this is odd. X needs absolute value. 2 doesn't. They're not bonded, so only x will get the absolute value. 36, we're page 752. No, I'm sorry, 40. I just did 36. 40. X plus 5 to the 8th power to the power 1/8. Again, we're going to do 8th root of x5 to the 8th, which is x 5 to the 1st power, and we must have absolute value because this is even and this is odd. And it's around the whole thing because of the bond. So just like when we have 1/n, the bottom is the index and the top is the power. So same thing with any fractional exponent like 64 to the 2/3. To evaluate this, the bottom is the index and the top is the power. Or you could write cube root of 64, you can put the power inside or put it outside and it would still be the same answer. Look, cube root of 64 square is cube root of 4096, which is 16. And cube root of 64 is 4. 4 square is also 16. So as a general rule, a to the m/n. Again, the bottom is the index, the top is the power. the power can be put on the inside or on the outside. It's easier to do it on the outside, but it doesn't matter. So let's practice this. 42, page 52. What's 27 to the 2/3? Again, the bottom is the index, so cube root of 27. You can put the square here, or on the outside, it's easier to cube root than square. Cube root of 27 is 3, 3 squared is 9. So look at this, 27 to the thirds is 9. Now if next to this I have 27 to the negative thirds, what do I get? Well, remember a negative exponent puts that under 1, which would give me 1/9, because I already got this to be 9. Okay, that's what the negative exponent is going to do. It's going to put the answer under 1. 46 from page 752. 4/9 to the 3/2. It's square root of 4/9. Again, I'm going to put the cube on the outside. That's 2/3 cubed. 2 cubed is 8. 3 cubed is 27. So if I say on the test, if I say evaluate 25 to the negative 5/2. Well, we all know a negative exponent, it's going to put my answer under 1 with a positive exponent. So I'll leave this alone. I'll do this first, 25 to the 5/2. And once I get the answer, then I'll put it under 1. Okay, so this is square root of 25 to the 5th power. 5 to the 5th, which is, I believe, 31/25. And the answer is 1 over 31/25. Okay, don't forget to put the answer under 1. Here's another one. 81 to the negative 3/4. Again, that puts 8 to the 3/4 under 1. Your answer is going to be under 1. So let's do 8 to the 3/4. Remember, the bottom is the index, so 4th root. 81, sorry, like it's not 8, 81. 4th root of 81 cubed. 4th root of 81, 3. 3 cubed is 27, so the answer is not 27, it's 1 over 27. Okay, so how do we evaluate 27 a cubed b cubed to the 2/3? Again, the bottom is the index, so it's a cube root 27 a cubed b cubed all square. That's 3ab, but now we get to square everything. If you square the 3, you get 9. A squared is a squared, and then b squared is b squared. And now if you say evaluate, knowing this, how do we evaluate 27 a cubed b cubed to the negative 2/3? Remember, that's going to put my answer under 1. So we have 2/3 here. We already got the answer for this. So here, so it's 1 over 9 a squared b squared. And if I want to do 25 over 49 to the negative 3/2. Remember, if we have a fraction with a negative exponent, we flip the fraction. And that's going to get you the negative exponent. That's a shortcut. So the bottom is a square root, and the top is a cube. So that's 7 over 5 cubed, which is 343 over 125. Okay. Next one is to simplify, assuming all variables are positive, so no absolute value is needed. Again, when we have a fraction to a negative exponent, the first thing I want to do is flip the fraction so I can get rid of that outer negative exponent. And the fourth root is what the 4 is for, 81 y4 over 16 cube. 81 is going to be a 3 when you fourth root it. Y4 is y. Again, no absolute value is needed because I'm telling you everything is positive. Fourth root of 16 is 2. When you cube everything, you're cubing the 3, 27, y cube, and then cube is 8. Now let's go back to page 752 in the book, number 78. We have 4 to the 2/5 times 4 to the 2/5. How do we multiply if the bases are the same? We keep the base as the first root of exponents, and we add the exponents. So that's 4 to the 4/5. That's all they want us to do there. 82 from that same page. B to the 3/5 times b to the 2/5 to the power 8. Now we always gotta try to do something about what's inside the disease before we go on the outside. Since the bases are the same, we keep the base and add the exponents. 3/5 plus 2/5 is actually 5/5, which is a 1. So it's b to the 1 to the 8, which is b to the 8. 88 b to the 4/5 times b to the 4/5 divided by b to the 3/5. First, we got to take care of this. It's timesing, they're the same. We add the exponents. 4/5, 4/5 is 8/5. Then we're going to subtract the quotient rule. 8/5 minus 3/5 is 5/5, which is just b. Number 90. Y to the 2/5 times y to the negative 2/5 plus y to the 3/5. Remember I told you to do what's inside the parentheses, but since it's addition and these are not like terms, there's nothing we can do. So we're going to distribute. So we're doing y to the 2/5 times y to the negative 2/5 plus y to the 2/5 times y to the 3/5. If you add 2/5 to negative 2/5, you get 0. And that's going to add up to 5/5, which is 1. Anything to a 0 power is 1. So the answer is 1 plus y. Number 96. Well, what they want us to do in 96 is to simplify this. I'll tell you what you can do there. To simplify this, you can write it as an exponent. The base is 13, the index is the denominator, and the power is the numerator, but you can reduce the 4 and the 12 but to 1/3, and then you can write it as the cube root of 13, basically. Okay, so basically you divide the 4 over 12, 12 4, you get 3, and that's going to be cube root. Okay, you get a 3 and it's cube root. And that's it for section 9.2.